Hello everyone, welcome to the next lecture on the linear algebra. Today we will discuss about examples related to the eigenvalue and the eigenvector. Myself, Dr. Garg, working in the School of Mathematics. You can simply follow my YouTube channel, Dr. Harish for finding the more various videos. What we have discussed so far, this is a playlist of the Mathematics 2. We have discussed the concept of the eigenvalue and the eigenvectors as well as the geometrical meaning of these eigenvalues. I can quickly recall that if you have any of the square matrix of order n, then you can find the eigenvalue by finding the roots of this characteristics equation a minus lambda I, where I is my identity matrix. The roots of this is called as the characteristics roots, eigenvalue, or called as the latent root. And the corresponding non-zero eigenvector or corresponding the non-zero vector is said to be the eigenvalue. The non-zero eigenvector is said to be the eigenvector if it satisfied this equation. Or I can written this equation as a minus lambda I of x is 0. That is, you have to find the corresponding value of the x for which a minus lambda I is the root of that. So this x is called as the eigenvector, called as the latent vector, pole, invariant, or the characteristics vector are there. There are some features, there are some remarks about the eigenvalues and the eigenvector. When you are trying to solve the roots of this characteristics equation, then the roots are maybe real, roots may be complex number, and if they are the real and complex, then they may be the distinct or they are in the repeated natures. So we denoted the roots as a lambda I. If the roots are my simple, that is what is the meaning of the simple is, that is the roots are my distinct, then the corresponding eigenvector are always be a linearly independent. Remember, if you have the eigenvalues like 1, 3, 4, then the corresponding to this one we will find the eigenvector x, corresponding to this we will find the x, corresponding to this 4 we will find the x, and all these eigenvectors are always linearly independent if they are distinct. On the other hand, if they are repeated root, then the corresponding eigenvector may or may not be a linear independent. The eigenvalues you can find like say 1, 3, 4. You may find as a minus 1, 3, 3, or you may also find as a 0, 1, 1 by 2 and so on. Or you can say you can 0, iota, minus iota and then so on. Once you are finding the eigenvalues, then the spectrum is the set of all those distinct values. Like if I write these are my eigenvalues, the set is 1, 3 is called as the spectrum of the eigenvalue. If you have the eigenvalue 1, 3, 4, the distinct eigenvalues are 1, 3 and 4. This is my spectrum. Once you are finding the spectrum of this, then the largest eigenvalue in the absolute term is called as the spectral radius. Like if you have 1, 3, 4, what is the largest eigenvalue in the magnitude? Here, this is called as the spectral radius. If you have the eigenvalue like minus 1, 3 and 4 and say 2, then again this is the largest eigenvalue. But if you have the eigenvalue like lambda is minus 3, 2 and 1, what is the largest eigenvalue in magnitude? That is a minus of 3, largest eigenvalue in the magnitude. So this is called as the spectral radius. Once you are finding the eigenvalue, then we can say if x is my eigenvector, then for every non-zero vector is also be the eigenvector. Or you can say the eigenvector is not always unique. Now based on this concept, we will explain 7 to 8 examples in this of the different kinds. The first one is that find the eigenvalue and the eigenvector of this. So what is that? You have to start from this a minus lambda I is 0. So here this is a 3 cross 3. So I is my 3 cross 3 values, that is a 0, 0, 0 and here. So once you substitute here, you can find the determinant of this. So it will be 1 minus here, minus of 0, minus 1, 0 minus 0, plus 0, 0 minus 0 is 0. So what is that? It is nothing but my 1 minus of cube is 0. Moreover, you can see that the lower values are always 0. So the determinant of this, if you have the values of a, b, c, 0, d, e, 0 and f, since the lower values are 0, the determinant will be a, d, f, that is a diagonal entries. So what are the roots of this? So it's a cubic, so there are 3 roots are my here. So what is the algebraic multiplicity? How many times 1 repeated? how many times this one repeats. So since it repeats 3 times, so we call as the algebraic multiplicity 3. So these are the eigens value. How you check your answer is correct or wrong? So since my eigens values are 1, 1 and 1, so you can find the sum of this. What is the sum is? 3. That is always be the trace of the matrix. So what is the trace is? The sum of the diagonals value. The sum of the diagonal value is my 3, which is same as that of the sum of the eigenvalue. Another rule is, if you find the product of this eigenvalue, what is the product is? 1, it must be equal to the determinant of this A. You can find that determinant of A. So if you find that determinant is a 1 is there. So you can see both are the here. So this is the way you can check your answer. Now we can start from the eigenvector, that is A minus lambda I of x is 0. Lambda is my 1. So this is a A minus I. So I can substitute the value of here as lambda is 1. So it will be the 0, 1, 0, 0, 0, 1, 0, 0, 0. X I can consider as x1, x2 and x3. Now you can try to convert this into the row reduced echelon form. So since it is already a row reduced echelon form, now you can multiply them. First line is x2 is 0. Second line is x3 is equal to 0. Now I can substitute this x2 and x3 at here. What is the value of the x2? x1 we don't know. x2 is 0, x3 is 0. So I can return this as x1 is outside 1, 0, 0. This is my here. So this value is called as my eigenvector of 1. Look at the next kind. So if there is a transformation, that is called as the linear transformation. So that's very simple. Look at that. Whenever there is a transformation of this to something, what are the, you have to find the basis of this. You have to find the basis of this. What is the basis is R2, that is a, what is the R2? That is the xy plane. So what is the x unit vector of the xy plane? Any vector on this is 1, 0. Here is 0, 1. So I can write the basis of R2 as 1, 0. This is for here and this value is for here. If it is R cube, we will also see in the next example. This is my R cube, x axis, y axis and z axis. Then firstly you have to apply t of this. What is the value of the b1? So 1, 0 and t of 0, 1. So we can compute the value of this. This is the x, this is the y. X, y is y, x. So this is my y, this is x here. Now can you write this in terms of here? Because this is the x-axis. X-axis is my 0, 0 of this. Y-axis is my 1. So 1, because you can see any vector in the R2 plane, it can be written as linear combinations of here. Now this is my x, this is my y. So if I substitute here x 1, 0, y 0, 1. Fine. So therefore you can write the matrix associated with them. The first one is a 0, second one is 1, third one is 1 and the last one is 0. So this is the matrix A. Another method is, you can also think about that how you can check whether this is right or wrong. You can write the matrix A. The first one is a y. The first column is my x. So this is my 0. Second is my y. If it is 1 and 0. If my values are say x plus y, 2x minus 3y, then what will be my matrix is x, y, x, y. This is my A. So now you can see that it matches also with the same. Now once you are here, you can find the characteristics equation A minus lambda. You can simplify them. You will get as a 2 different value. You can also check whether your answer is correct or wrong. You can find the sum of them. What is the sum is my 0 and you can see the sum of the trace. The trace is also 0, sum is 0. What is the product of them? Product is my minus 1. Find the determinant of A. This is also be a minus 1. So these values are my correct. Now find the eigenvectors. We can find the eigenvector corresponding to 1 and second is minus 1. Now we can substitute the value at here. So once you will substitute 1, you will get as here. Now you can make them as a row reduced echelon form. You can convert them R2 plus R1. You will get as here. So since it is a row reduced echelon form, you can write this as x plus y is equal to 0. And what is the value of the x? X is nothing but my y. you can substitute the value of the x is y as here. This is y, this is y. So there is only one independent variable, y as a common. So 1 comma 1 is my eigen vector of this corresponding to lambda is 1. How you can do that? So I can again write as r2 minus r1. You will get as here. I can simplify this, x plus y is equal to 0. So value of the x is my minus y. So I can substitute here minus y plus y. So y is common, minus 1 plus 1 is the right answer of this problem. How you can check whether your answer is correct or not in the examination? Now you can see my eigenvalues are minus 1 plus 1 and both are my distinct. So once they are distinct, you can check the corresponding eigenvectors are my Li. Fine. So how you can check that whether it's Li? You can find this is the first vector 1 comma 1. The second vector is minus 1 comma 1. If you find that if I call as this is a m, find the determinant of m, it is always be a non-zero. You can see 1 plus 1, 2, which is a non-zero, it means they are Li. It means these answers are your correct options. Okay, look at the another one. Now in this case the matrix is already given to you. Now you can see again the lower values are 0. So it means my eigenvalue will be a 1 1 1 because the eigenvalues are always be a diagonal values. Anyhow, we can start with the a minus lambda I is equal to 0. That is the characteristics equation. You can open this bracket, you will get as here. We can find the eigenvector. So what is that? If I substitute lambda is equal to 1 here, so it is a 0 1 0 0 0 0 and here. So from after simplification you will get x2 as a 0. I can substitute here x1 we don't know, x2 0, x3 we don't know. So I can, since there are the two unknown parameters, one is x1, second is x3. So I can substitute the value of the x1. This is the first value 1, 0. There is no x1, it's a 0. There is no x3, there is no x3, there is x3. So these two are my eigens vector corresponding to lambda is equal to 1r here. Okay, look at this one. Now here you can see the diagonal values, the lower or upper are not 0. So it means the diagonal values are not be a 1, 2, 3. So we can start from here. So I can expand this one. So it is 2 minus lambda, 3 minus of 0, minus 6, that is a 3 minus lambda minus 0 plus 0 is equal to 0. So how you can solve that? Either you can open this bracket, otherwise I can make this 3 minus lambda as a common. So if you open that, 2 minus of 3 plus minus 6 is equal to 0. So what is that? This is a 3, I can written as lambda square minus 3 minus 4 is equal to 0. Can you make this factor? So 3 minus, I can this as a 3 minus 4 plus 1 is equal to 0. So what are the eigenvalues? Minus 1, 3, 4. These are my eigenvalues corresponding to them. You can check your answer, whether your answer is correct or not. What are the sum of the eigenvalues? That is a 6. And you can see the sum of the diagonal values also be a 6. What is the determinant or what is the product of this? Product is my minus 12. So if you find the determinant of this, you will get as a minus 12. Now, since there are the three different eigenvalues, we can find the three different eigenvectors. First one is corresponding to minus 1. So I can substitute here as minus 1. So what is the answer of this? It is a plus of 2 and here. Now you can make them, how you can make them as a 0? Either you can use them as R2 minus R1 over 2, or otherwise you can make them as R1 interchange R2, or you can make them R1 as R1 divided by 2. X on your choice. So I can make this as here. Now I can make this value as a 0. That's very simple. R3 I can make them as a R3 plus 2 times R2. So this will give as a here. Now you can write this expression as 2x1 6x2 plus x3 is equal to 0, and the next one is minus 2x3 as a 0. So from here we will get as a x3 0. From here we will get x1 as minus 3 because x3 has a 0, so I can find the value of x1 and x3 here. So I can substitute this value. X1 is minus 3x2, x2 we don't know, x3 as a 0. So x2 as a common, we can say minus 3, 1, 0 are my eigens vector corresponding to lambda is minus 1. Same, we can find the eigenvector corresponding to 3 and 4. For 3 and 4, we can substitute the value at here, 3 and 4, you will get these expressions. Now, you can write either R2, how you can do that, plus R1 by 2. So, this part will be 0, or you can simply write as a simple expression. You may also write 2x1, 6x2, 1x3, x1 here. So, from this, we will get x1 as x2. If you substitute here, you will get 4x2 plus x3 is equal to 0. Fine. Now here you can substitute this value. X1 is my in terms of x2. X2 is my x2. X3 I can written as a minus 4x2. So what is the eigenvector corresponding to lambda is equal to 3? 1, 1 minus 4 here. Or you can find the value of the x2 also from here. What is x2 is minus x3 by 4. Then what is my x2? x1 is x2. x2 is my here. x2 is my this. And x3 is my here. Then the eigenvector will be minus 1 by 4, minus 1 by 4 and 1. So either you can write this or this. How you can find the corresponding to 4? We can open this as a R2 and simply I can multiply this by 3 and add them below. You will get here. I can add them here. You will get as a 0. So we can see x1 minus 2x2 is 0. x3 as a 0. So I can substitute here. You will get as the expression of this one. So now you have the 3 eigenvector, this and 1 corresponding to this, because these are the distinct. You can write the value corresponding to 1, 1 minus 4. Previous value is my here and 2, 1, 0, and find that determinant, it always be a non-zero. Okay, one more examples are there. Now this value are here. We can start with this. We can expand its determinant. We will get as here. So clearly says 0, 3, 3 are my eigens values. We can start with the lambda is 0. We can substitute the value of lambda 0 here. We will get here. Then you can simply write R2 minus R1 and R3 as R3 minus R1. This one. So what is the answer of this? X1 plus X2 plus X3 is 0. So I can substitute the value of the X1 here. X2 minus X3, X2 and X3 are here. So I can write this corresponding. There are the two unknown variable. One is X2, second is X3. So what are the coefficient of the X2 in here? Minus 1, 1, 0. What is the coefficient of the X3? Minus 1, 0, 1. So these two pink colors are my eigens vector corresponding to lambda is 0. Now we can find the eigenvalues, eigenvector corresponding to lambda is equal to 3. We can write here. We can convert into the row reduced echelon form. Our target is to convert into row reduced echelon form. So we can get as here. Now you can see, you can simply add them, R2 plus R3, you will get here. So what you can do, you can write this equation as here. So from this we will see x2 is equal to x3. I can substitute x2 and x3 here, you will get this expression. So what is the value of the x? You can substitute 1, 1, 1 are my eigenvectors. The last example here, you can find this one. Now what is that? This is R cube. What are the bases of R cube? Standard basis. That is my I cap, j cap, k cap. This vector I can written as a 1, 0, 0. This vector I can written as a 0, 1, 0. This is 0, 0, 1. Then what you can do? You can find the values of this 0, 1, 0. You can find this value as here. Fine. So 1, 0, 0. If you substitute here, it will be 3, 0, 0. Similarly, you can write as of this. Now you have to take any element of this. What is that? X, Y, Z. So can I written this element in the terms of the standard basis? 0 1 0 plus 0 0 1. So I can return this is x y z. So x 1 0 0 plus y 0 1 0 plus z 0 0 1. Similarly, I can write for the other parts. You can also verify your answer is correct or not. You can simply open this bracket, x coordinate, add them x, we will get here. So what is the matrix of the A corresponding to this linear transformation? The first row is my 3 0 0 1 2 0 and 4 6 5 is my eigenvector, is my linear matrix corresponding to the transformation. How you check whether this is wrong or correct or wrong? You can see here. You can write the coefficient of the x, coefficient of the y, coefficient of the z, coefficient of the x, y, z, 0, 0, 5. You can see both are my same. Now once you are here, you can find again how you can find the eigenvalue. You can start from here. Otherwise, you can see the below diagonal entries are my 0, so eigenvalues must be 3, 2 and 5. Otherwise, you can simplify this, you will get as of this. You can check your answer. Sum of the eigenvalue is my 10, product of the eigenvalue is my 30. You can find the trace of the matrix, you can find the determinant of the matrix. So trace of the matrix you can see is a 10, determinant is also 30. Now there are the three different values. We can start with the eigenvalue corresponding to 2. We can substitute this value as here, it's a 1 1 4 and here. How you can do that? I can see, I can take them R3 minus 1 by 2 of R2. You can write as here. Now I can write x, y, z. So x plus y plus 4z is equal to 0 and corresponding to them is a 6z is equal to 0. So from here we will get z as a 0. So what is the value of the x? X is minus y, z is 0. I can substitute value at here. So this is my minus y, z is my 0. So y as a common, minus 1, 1, 0 is my eigen vectors. Or if you write in the curly braces, we call as the basis corresponding to eigenvalue 2. Similarly, corresponding to lambda is equal to 3, we can substitute here. So I can simply, what you can do, I can make them this as a 0. We can write as of this. You can simply add them. Now I can divide this by 5 and subtract them, you will get here. So I can written as y plus 4z is equal to 0 and 10z is equal to 0. So what is the here? So from this we will get z as a 0. If you substitute here, we will get y as a 0. So what is the value of x? It is unknown, y is 0, z is 0. So I can take x as a common. 1 0 0 is the standard basis, is the eigenvector or the basis of the eigenspace corresponding to 3. The third eigenvalue is corresponding to 5. We can start from here. Now what you can do, this is already a row reduced echelon form. Now you can simply write as a 2x plus y plus 4z is equal to 0 minus 3y plus 6z is equal to 0. So from here you will get y as my 2z. If you substitute y here as a 2z, so it will give as a, what is the value of the x? X is my 3z. So I can substitute the value here, x, y and z. So what is that? Z is my common, 3, 2, 1 is my eigen space corresponding to lambda is 5. So since this is the one eigen value, the other two eigenvalues are my this and this. So if you write the matrix and find the determinant, it always be a non-zero because the eigenvalues 2, 3, 5 are my distinct. So this is the way you can solve this eigenvalues problem in a very simple manner. I hope you can simply learn the concept in a very simple manner. You can simply like, share and comment on my videos. You can share with your friends. Best of luck students. Happy learning.